Welcome to Chapter 10, Section 6, entitled Volume of Rectangular Prisms. Volumes of rectangular prisms are very similar to the area of a rectangle. And there's a lot of different formulas you can use. The main formula we're going to use today is the volume V of a rectangular prism is the product means multiply, of its length times width times height. So volume equals L times W times H in any order that you want. Basically what you're doing is you're taking, if you look at just this part, if you look at just the volume equals L times W, length times width, that's volume equals the area times the height. So what you're going to do is if you've got a little square, find the area of it and then multiply by that third dimension, and that'll give you your volume. So the bases of a rectangular prism are congruent rectangles. The amount of space inside a three-dimensional figure is the volume of that figure. And volume is measured in cubic units. That means cubic inches. That means cubic centimeters. That means cubic meters. That means cubic feet. It means there's a exponent is a 3. All right, find the volume of a rectangular prism. All right, the volume formula is this. So we look at this right here and we just have to decide, what do we want the length to be? What do we want the width to be? And then the height would be 5. So you plug all those numbers in there. 8 times 10 times 5. So that's, let's see here, let's do this one. That's 80 times 5. And all together, 400. And that's 400 cubic meters. You need to make sure you put the units. Don't forget the units. All right, and then this is the second formula. All right, this is what I said over here. That is the area of the base. So there's two formulas you can use. This is formula 1. This is formula 2. You take the area of the base. So B, the area of the base, is, all right, here's the base. It's not a square, it's a rectangle. And this side right here is congruent to this side up here. So it's 10. The area of the base is 8 times 10, or 80. Now, the area of the base, since B, the area of the base, is 80, and H is 5, we do 80 times 5, which still gives me 400. So the volume is 400 cubic meters. Now, the reason this is better is that it works for all prisms. If you know the area of the base, then, and the height, you can find the volume. Whether it's a cylinder, whether it's some triangular shape, or whatever the shape is, you will be able to find it if you know the area of the base times the height. Now, I know this says to explain in your own words the difference between a two-dimensional figure and a three-dimensional figure. But basically, if you think about two-dimensional, let's say that 2D is only up, down, or right, left. Only two dimensions. Dimension 1, dimension 2. There is no other dimension. It's a flat surface. Whereas 3D is 2D with a forward and backward movement, which is where the third division comes into play. So that is a big difference right there. All right, find the volume of this. So you should actually probably pause the video and either use length times width times height, or the area of the base times the height. Either one will give you the same solution. But these are the formulas that you must write down. So let's use this one. 12 for the length times 3 times the height. Well, the height, I'm sorry. The height is actually 4. So that's 12 times 12, 144 cubic inches. Over here, first start with the area of the base, which is 12 times 3, which is 36 times h. H happens to be 4, so it's 36 times 4, which is also 144 cubic inches. That's the volume using the two formulas. All right, use volume to solve a problem. Here we go. A closet is 6.2 feet long, 2.8 feet wide, 8.1 feet high. Find the amount of space contained within the closet for storage. So we're going to start by estimating 3 by 3. Oh, I'm not sorry, not 3. 6 by 3 by 8. Well, that is approximately 144. So any number that we get that's close to 144, we should be happy about. So let's go ahead and find this volume with LWH. Well, let's draw a picture of a closet. Well, that closet really should get rotated a little bit. All right, and then that's a two-dimensional, and then here's the rest of the dimension. So it says that this thing is 6 feet long. I'm sorry, 6.2 feet. 2.8 and 8.1. So the length, 6.2. The width, 2.8, and the height is 8.1. So plug those numbers in there. And unfortunately, it's going to cause the numbers to be kind of screwy. Meaning you first have to do length times width, which is 6.2 times 2.8. So the area of the base is 16.36. Now we're going to multiply it by the height, which means we're multiplying by 8.1. And we multiply again. 6, 3, 6, 1. That's 48. Carry the 4. 24, 28. Hey, I gotta make a quick correction here. When I did this last addition here, I didn't carry a 1, which would have made this 7. Alright, so erase that. You may have to just start it over again. Sorry. So let's do it again. See, that's 48, 24, 28, 56, 58. Alright, well, you see that I got a 70 here for some reason. I think I made a mistake because we know the answer, and maybe I did it on purpose. We know the answer should be close to 144, but we don't. It's not close to 144. So I'm going to go ahead and I'm going to start this multiplication process over again to make sure I didn't make some mistakes anywhere. So again, length times width times height, 6.2 and 2.8. 8 times 2 is 16. Carry the 1. 8 times 6, 48. Carry the 1. 49. Placeholder. 2 times 2 is 4. 2 times 6 is 12. That's a 6. That's a 13. Carry the 1. 7, 1. 2 decimals. 2 decimal places. So now I've got 17.36 times 8.1. And let's multiply. 1 times 6. 1 times 3. 1 times 7. 1 times 1. Placeholder. 8 times 6 is 48. Carry the 4. That's 24. Plus 4 is 28. Carry the 2. 56, that's 58. Carry the 5. That's 8. That's 13. Add. To 100. Oh, there. Then there's 3 decimal places. So 1, 2, 3. So my answer is approximately 140.6. So the amount of space, 140.6 feet cubic feet. That's how this works, and I'm sorry for all the little mistakes. All right, so we're almost done. We have a box. There. And the box provided by a mover for packing. There we go. There's your box. It is 4.5 feet long. It is 2.5 feet wide. And then it is 5.5 feet high. So we need to set up volume is equal to the length times width times the height. Please don't forget that length times width is area. So 4.5 feet long times 2.5 feet wide times 5.5 feet high. And let's go ahead and estimate. Let's say 3 times 5 times 6. That's 15, or that's 30 times 3, so our answer should be 90. It'll be less than 90, but it should be close to 90. Or in the ballpark. Alright, now let's see if I can do this without making mistakes. 4.5 times 2.5. That's 25, carry the 2, 22. 5 times 4, 20 plus 2. Then we've got 10, carry the 1, 8, 9. So 5, 2, 11. 11,000, or 1,125 with 2 decimal places. So now I've got length times width, 11.25. Let's multiply by 5.5. That's 5 times 5, 25. 5 times 2 is 10, plus the 2. 5 times 1, 5, and 1 is 6, and 5. The next number. 5 times 5, oh, it's 5. It's this number all over again. So when we add 5, 7, 8, 11, so it's about 61.9. Alright, so somehow the video stopped, but hopefully you see the drawing, the dimensions, the multiplication, 4 times 5 right here, and then that number times this ended up with 61.9 cubic feet. And then you should see all the problems that we're going to end up doing. 1 through 6 all from the CYUs, and these problems in class. Good luck.